Understanding multiplexers. This presentation explores multiplexers, in short MUX, in digital logic. We will uncover their crucial roles in data selection and routing, essential for modern electronics. Move on with me as I delve into what multiplexers are, how they work, and what they are used for. What is a multiplexer? A multiplexer is a combinational circuit. It selects one of many input signals. Think of it like a multi-lane highway merging into a single main lane. We have other things like data selector. So, in a multiplexer, we have a data selector. This routes one input from many. Then we have a combinational logic. The output depends only on current inputs. And then we have the essential component, which is crucial for digital systems. Let's take it a bit further. What is a multiplexer input and output? A multiplexer has multiple lines, select lines, and a single out line. Specifically, for n select lines, which means for any number of given select lines, there are 2 raised to the power n inputs, meaning that our number of inputs would be raised to the power 2, or 2 would be raised to the power the number of inputs to get our select lines. What are the input lines? They are the data sources. The select lines are the control of the data flow, and the output line are the single data stream. Moving on, the input lines each carry signal. The select line determines the chosen input, while the output line is the final result. Moving on, let's look at the selection process. Select line determines which input connects to the output. A binary code on these lines chooses the input channel. For instance, a 2-to-1 max requires one select line, which is the S0, a binary code. It is applied to the select lines. The internal switch, it is activated by the select lines, and the input routed. Selected input moves to the output. This is the place where the selected inputs move. Let's look at an example in the form of a truth table. A truth table clearly shows the inputs and outputs relationship for a 4-to-1 max with 2 select lines, which is S1 and S0. If S1 is equal to 0 and S0 is equal to 1, the inputs at I1 is routed to the outputs as the truth table shows. On our truth table, we have the first input 0 and the second input 0 given as I0. The first input 0, second input 1 given as I1. The first input 1, the second input 0 given as I2, and both inputs are the last given as I3. The image is a 4-to-1 multiplexer. This device selects one of the 4 input signals, I0 to I3, and routes it to a single output based on the values of 2 select lines, S0 and S1. Here is how the selection works. So if S1 is 0 and S0 is 0, the output will be I0. If S1 is 0 and S0 is 1, the output will be I1. If S1 is 0, if S1 is 1, and then S0 is 0, then the output will give us I2. If both S1 and S0 are 1, the output will give us I3. The diagram shows logic gates involved. NOT gates for inverting the select lines. The AND gate for selecting the appropriate input, and then the OR gate to combine the outputs of the AND gate. A multiplexer is a key component in digital systems, as said in the previous slides, allowing for multiple data streams to share a single transmission line or resource. Thank you. Now let's look at the behavior logic creation, data conversion for parallel to serial streams, and then we have line reduction. This simplifies the system's wiring. It's just like having a multiple highway merging into just one way road. Okay, it simplifies everything. It's the same way it is easier to create a single lane road compared to that of a 5-lane highway, a 4-lane highway, and so on and so forth. So those are some of the basic applications of multiplexers: data routing, function generation, data conversion, and lastly we have line reduction. Just
presentation. But before we leave, let's take just key takeaways. So, multiplexers are essential for data selection. They simplify circuit design. Their use significantly reduces overall complexity, as given with the example of parallel to series. This makes them fundamental in digital systems. So they can be used for data selection, which is the core functionality. And then we have circuit simplifications. This streamlines designs, and then complexity reduction. This enhances efficiency. Thank you for watching my video, and I hope it helps you understand the use of multiplexers, how they work, then significance in society.